Simplifying rational expressions. So reducing rational expression, let's reduce the fraction 12 over 18. Be aware, this is sort of a review. So we have 12 over 18. We can break it down into multiples. For instance, one set of multiples is the 12 can be converted into a 6 times 2. The 18 could be converted into a 6 times 3. 6 times 2 is 12, 6 times 3 is 18, right? So notice there's a 6 on top, 6 on the bottom, so we can always cancel the 6's, leaving us with the 2/3 and as a result, as you have at the end there. Or likewise, we can go a little bit further into its prime multiples. So it could be converted into 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12, right? So it gives us 12 again. And on the bottom, 2 times 3 is 9. 9 times 3 is 18, right? Okay. Pardon me. Wrong number. 2 times 3 is 6. 6 times 3, 18. There we go. Right number. So in this case, notice that we have a 2 on top, 2 on the bottom. We can cancel each other out. Likewise, we have a 3 on top, 3 on the bottom. We can cancel each other out. So therefore, we have left 2 over 3, or 2/3, just as we have at the end once again. So more than one way to simplify. Be aware of that. And likewise, when you're trying to factor, sometimes you can simplify by factoring. So let's try that out. Let's see how it works out. But first, let's review some factoring formulas. So first one we want to review, for perfect square trinomials, we have a plus b quantity squared, and we can convert back and forth from the factored into the expanded format. A squared plus 2ab plus b squared. We also have the difference of two squares, which is a squared minus b squared is equal to a set of parentheses, a plus b, times another set of parentheses, a minus b. Notice one's positive, one's negative. And likewise, our last form of factoring, there are more, but be aware, this is just the three that we're kind of looking at the moment. We may not need all three though. Trinomials, quadratic equations in other words. Ax squared plus bx plus c format. Be aware, this is when your a value is 1. So if a is 1, this is the kind that we're using. If a is not 1, we're not using it just yet in this case. And if it looks similar to that, ax squared plus bx plus c, we write multiplied equals. We look for the multiples that produce the c. And when added, the multiples that produce c should be added to give you the v value in this case. All right, so now that we checked, let's try factoring the difference of two squares. Let's notice that x squared minus 25 on our example there at the top is technically a difference of two squares because there's an x squared minus 25. What number squared gives us 25? 5, right? 5 times 5 is 25. So this can be rewritten as x squared minus 5 squared. Now we can see that it actually does look like a squared minus b squared. And therefore we can factor into two sets of parentheses. One where you're adding, the other one you're subtracting. The first value is your a value, so our x goes there on each one of those because it's our a value. And b value is the 5. No negative or square value on there, okay? Just the 5. So there's our 5 here and here. There it is. We're done factoring that one. Pretty quick, right? So our next case, x squared minus 7x plus 10, well, that sort of looks like the very bottom, or it could look like our perfect square trinomials. If it was a perfect square trinomial, the middle term, when you multiply the squares of the two sides, or the left and the right side, the a squared and b squared, should give you the middle term. But is there a number squared that gives you 10? 2 times 2 is 4. 4 times 4 is 16. Too high. 3 times 3 is 9. Too low. No. So there's no exact number that gives you 10 in that case. So it's definitely not a perfect square trinomial. So let's try trinomial quadratic or quadratic equation format. So let's write it out. X squared minus 7x plus 10. And let's realize that we're looking for the multiples that give us the 10, the one that has no x. And when added, it should give us the b value, in this case, of negative 7. Be aware, it includes the sign. It includes the positive on that 10 and the negative on that 7. So multiples that give us 10. 1 times 10 and 2 times 5. Be aware, we have to make them negative in this case because we have to get a negative 7 when we're adding. But because they're both going to have to be negative, in order for us to get a 10. that's a positive. So do realize the signs kind of work their way in there once you check your values. If I multiply 1 times 10, still 10, negative times a negative, still positive 10. 2 times 5 gives us 10, negative times a negative, still positive 10. So it works. For our multiply. Add it, let's try them out now. Negative 1 minus 10 gives us negative 11. That's not negative 7, agreed? So that doesn't work. How about the next one then? Negative 2 minus 5. Hey, that works. It gives us negative 7. 2 plus 5 is 7, technically, but they're both negative, right? So I borrowed both of them. Or you can say negative 2 minus 5 gives you negative 7. Different way of visualizing this, if it helps. So let's realize that we just found our right combination. So choose set the parentheses. When we're factoring in this format, we always put an x at the beginning. Since the a value is 1, we don't have to worry about giving extra space at the beginning. And in this case, we're just writing down the negative 2 and the negative 5 in each of those sets of parentheses. There's a negative 2 in that one, negative 5 in that one. You're welcome to reverse the order of the 2 and the 5. Totally fine. Since you got the right sign on them already. You're welcome to check by distribution as well. But for now, let's assume we got the correct answer. Since we kind of already checked. We did a check by writing our multiples and additives. So in this case, let's go back to our original expression. Let's write it down. Original expression, x squared minus 25. And we're dividing by x squared minus 7x plus 10. Okay, and notice we just factor both of them. That's our previous workout up at the top. We factor both the top and the bottom. So let's write it down. Let's replace them. So replacing the x squared minus 25 with the factor form of x plus 5 in one parenthesis and the other parenthesis x minus 5. So that's our a squared minus b squared factoring that we did. On the bottom, we're going to write our x minus 2 times the other set of parentheses, x minus 5. That is our quadratic equation factoring or trinomial factoring. And let's realize, what can we notice there? There's an x minus 5 on both the top and the bottom. So similar to numbers, when you can cancel numbers on top and numbers to the bottom. Here's the reason why we did that previously. We can cancel factored portions. That x minus 5 is the same as that on the bottom x minus 5. So it can cancel out. So that means we have left x plus 5 over x minus 2. And technically there's nothing multiplying on top, nothing multiplying on the bottom, so I don't really need the parentheses. So let's rewrite it without parentheses. That's our final answer. X plus 5 on top over x minus 2. And we can't simplify any further because there's no common terms to cancel. I realize there's an x on top, x on the bottom, but because one's adding, one's subtracting on the bottom and top, vice versa, we cannot cancel them out unless they were exactly the same. So there is our final answer for this case scenario. Let's realize factoring helped in this case. So now that we were able to factor, let's go on to one more step for reference in this case. Have you heard about the zero factor property? Well, zero factor property just implies that we're trying to find when does it equal 0. That's all it means. When do you get a 0? When can you get a 0? So let's bring back what we just previously had up above. But before we cancel it out. There we go. X plus 5 times x minus 5 on the top divided by x minus 2 times x minus 5 on the bottom. This is the exact same problem as what we were working on earlier, except I'm looking at it before I cancel the x minus 5s. Okay? Be aware of that. When do we get a 0? So the zero factor property, if a and b represent real numbers, and if a times b equals 0, then either a is 0 or b is 0, or both of them are zeros, right? But then again, if both were zeros, then we would say both are a or both are b's. So what numbers are not acceptable in the previous problem? Because they'll cause headaches, right? So what numbers cause the 0 in the denominator? So looking at the denominator, if any set of parentheses on the bottom is 0, then we get an undefined answer. So you can't divide by 0, right? So 0 times anything makes the denominator become 0. So when do we get a 0? For that, we have to separate this bottom expression out. So let's separate into two sets of parentheses. Separate out. First set of parentheses, x minus 2. And let's rewrite it without parentheses, x minus 2. And we're trying to find when does this equal 0. So set it equal to 0 in order to find that out. And now we solve. Plus 2 to both sides to solve for x. And that tells us that x equals 2. If x equals 2, we get a 0. If we were to plug that back into our denominator up above, plugging it in for the x, we would have in one set of parentheses 2 minus 2 would give us a 0. 2 minus 5 would give us negative 3, but negative 3 times the 0 that we got for the other set of parentheses, it's equal to 0. So we would get a 0 in the denominator. It wouldn't matter what else we have on top, because once you divide by 0, well, the answer is undefined. Agreed? So we found one particular case when we get a 0, and that's when x is 2. So once again, this produces a 0 in the denominator. Let's go for the next one, the x minus 5. And let's get rid of the parentheses in this case. So x minus 5 equals 0. And let's solve for x. So let's get rid of the negative 5, so it's plus 5 to both sides. Cancels out. X equals therefore positive 5. 0 plus 5 is 5, right? So when x is 5 is the other case scenario when we get a 0. And once again, this produces a 0 in the denominator. So if we try substituting a 5 in, 5 minus 2 would give us positive 3. In the other parentheses, 5 minus 5 will give us 0. Positive 3 times 0 is still 0. So you see, it wouldn't make a difference. We still get a 0 in the denominator, giving us an undefined answer. So here it is. This is when we get a denominator of 0. And that's searched, in this case, using the zero factor property. Be aware, you use the zero factor property in other formats as well, not just to check for when you get a 0 in the denominator. Agreed?